And when you hear types of fractions, you instinctively try to ask the question, on what basis is one type of a fraction different from the other? So I've classified them based on the basis for the classification and also the types and the relationship between one type and the other. So we'll look at those types and the basis for their classification. We'll look at each one of them and its relationship with an adjacent one or its difference from all other fraction types. So let's begin. The first one is a common fraction or a vulgar fraction. Common fractions are fractions in the form a over b. They are fractions in the form a over b, where b is not 0. B is a non-zero number. So, and you can understand the reason. You can't divide by 0, so b cannot be 0. So, with this knowledge that based on the structure of the fraction, we call it a common fraction. Based on how it's written, we call it a common fraction. That's why I classified it under the structure. So it's written as a over b, and that's a common fraction. Now, let's go into the types of common fractions we have, the types under the common fraction, the subtypes. We have proper fractions and improper fractions. A proper fraction, proper, is where the fraction has a numerator less than the denominator, where the a is less than b. And we can have examples like 1 over 2, 3 over 5, 7 over 14, and so on. So that's just about it for a proper fraction. It's a common fraction that has the denominator greater than the numerator. And if you look at my list here, I have a special case of a proper fraction here. And that special case is a unit fraction. A unit fraction is a proper fraction where the numerator is 1. So it's just a special case of a proper fraction where a is equal to 1, then that is unit fraction. The next type of fraction is an improper fraction. An improper fraction is where you have the denominator being less than the numerator, or you have a greater than b. The numerator is greater than the denominator. You have a large number on top of a small number. And examples of these are when you just flip these. You can have 5 over 3. Instead of 3 over 5, you can have 14 over 7, and so on. But now, this is all interesting. Let me summarize the lesson here by writing a type and its example, and then we'll move to the next section. So here is the summary for all of them. A common fraction is a fraction in the form a over b, where b is not 0. A proper fraction is a common fraction where the a is less than the b. Examples are 1 over 2, 4 over 10, 9 over 70. Done. An improper fraction is where the a of the common fraction is greater than the b. Examples are 5 over 3, 100 over 7, etc. And a unit fraction is a special case of a proper fraction where the a is just 1. For example, 1 over 2, 1 over 4, 1 over 10, 1 over 7. Done. So now let's move to the next part, which is mixed fractions. Have you ever heard of 1.5, 2.5, 3.25, and so on? Things like this. etc. Have you ever heard these ones being mentioned somewhere? This is how they are written. You write the whole number you mentioned first. It consists of 2 parts. One part for the whole, and the other part called the fractional part. And they are written side by side like this. No operation between them. So if you see a number like this, it is called a mixed fraction. The reason is that the fraction has a mixture of whole and fraction. So the fractional part and the whole part. That's just about it. It's just the notational way of writing it. There is nothing critical about it. And that's why I still classified it under structure, because it's based on how it's written and how it appears that it's called a mixed fraction this way. But this is another way to just write improper fractions. I'll show you in a minute why that is true. So mixed fractions help us express the idea of a whole and a portion. So let's say you're counting things and then you count a whole lot of unit things. Let's say you count 1, 2, 3, 4, 5, and then you get to a number, but the remaining one is not up to 1 unit. So you represent that by a fraction. And this is how we write it. You write it in the form of a mixed fraction. And that's the concept of mixed fractions. Helps us to represent a whole and a fraction together to mean the idea of quantifying something. So you've quantified it by mentioning the number of unit quantities plus the fractional part that is not up to a single unit. Yes. But beware that a mixed fraction cannot be written as something like this. 2 whole number 5/3. That would be a violation because the fractional part in itself has a hole in it. You would see that during the division, there will be a remainder of 2, which makes this in itself a mixed fraction. So it isn't technically inaccurate. The values will be the same, but this is kind of notationally wrong. We are writing the mixed fraction because we want to have a proper fraction. We want to manage the improper fraction we have, and then you go ahead and write an improper fraction in the mixed fraction. That would be wrong. So that's why you can't have an improper fraction in a mixed fraction. So that's it. So let's summarize what we did on mixed fractions and continue to the next section. So this is the summary of mixed fractions, and it's defined this way. You have a whole number and a fractional part attached to it. And this is how it looks like, where B is less than C, or in other words, B over C is a proper fraction. So you'd have the fractional part must always be a proper fraction. Examples of these are 1 whole number 1/4, 2 whole number 7/11, and 3 whole number 3/7. So the chapter for the mixed fractions is closed. We should go to another concept which is very crucial for this. We have to do conversion. The origin of the mixed fractions is from improper fractions. It's a nicer way to write improper fractions or handle them. So in that case, we'd go and look at how we'll convert back to improper fractions, or how we can convert from improper fractions to mixed fractions. So that's what we'll be doing next. The way that we do this is to first multiply the denominator by the whole part and then add the numerator. Here's how we do it. We go from 4 to 1, and then the results from there will be added to this. So multiply, add. The results you get from these two consecutive operations is what you use as the numerator of the resulting improper fraction. So let's go through the procedure for this particular fraction. 4 times 1 is 4, and 4 plus 1 should be 5. And that will be the numerator. And then the denominator will always be the denominator that was already in the original fraction, whether we are converting to improper fractions or from improper fractions. So here. And next is this one. We do the same thing, do a multiplication and then an addition. We'll get 2 times 11, that will be 22, plus 7, that will be 29. And that will be our numerator. The denominator will always be the same in both fractions, whether the destination fraction and the source fraction. So in this case, 11. So once we know what the denominator will always be, let's just write it in this case and then wait for the numerator. So how do we find the numerator in this case? We do a multiplication and then an addition. 7 times 3, that would be 21 plus 3, that would be 24. So 24 over 7. And that's how you change from mixed fractions to improper fractions. And now the next thing to do is to reverse the process. Rather convert back from improper fractions to mixed fractions. So let's do that. And for this one, what you have to do is to do a division, get the quotient, get the remainder, and use those together with the denominator to write the mixed fraction. So let's see how that is done. So the way to do this conveniently is to use long division. This is how the division would work. We'll use long division, and so we'll call the numerator and denominator dividend and divisor respectively. But because it's a division, if what you are calling it is a fraction, then the parts are numerator and denominator. If what you are calling it is an operation division, the top and the down would be dividend and divisor respectively. So let's set the dividend and divisor up the way it should be in a long division. So the divisor would be outside while the dividend would be inside. First, you have to kind of estimate how many times the dividend would divide the divisor. We'll put that as our quotient. The remainder would be the remainder that we would use. So how many times does 13 divide 4? That would be 3. It will be a 3, and 3 multiplied by 4 will be 12. And then we do a subtraction to get 1. So that would mean that our quotient is 3. That would be the big number that is always in the fraction. That will be the whole number part of the mixed fraction. And the denominator always remains the denominator as it is. And then the remainder will be the numerator of the mixed fraction. So let's write it up and then go on. So here you have the quotient 3 whole number. Remainder was 1 over 4. And then we move to this one. We would have the long division, 51 inside and 8 outside. How many times does 8 enter 51? That would be 6 times, about 6 times. So 6 here, and do the multiplication, you get 48. If you do the subtraction, subtract 48 from 51, you would get 3. That would be our remainder. And now how do we write the mixed fraction? We take the quotient. And now how do we write the mixed fraction? We write the quotient as the whole number, the remainder as the numerator, and the denominator in the previous fraction as the denominator. So that's how easy it is. So let's write it down and then move to the next one. So 6 whole number, 3 over 8. Okay, the last one. The dividend will be inside, which is 37. The divisor will be outside, which is 7. And 7, how many times does 7 go into 37? That will be 5 times. 5 multiplied by 7 should be 35. And then if we compute the difference, we'll get 2. That is our remainder. So the same way we write it, we write the quotient as the whole number part, and we write the remainder as the numerator of the fraction, and then the denominator of the fraction would just be the original denominator 7. And so we would have 5 whole number 2/7. And so this is how we also convert from improper fractions to mixed fractions. And that part of types of fractions is done. So in the next part of the video, we will be dealing with the types of fractions based on representation, based on how we represent them. And we'll also look at the types of fractions based on relationship. And there is another one which I classified as complex fractions, which would be under structure, but a special kind of structure.